Welcome everyone for this lecture. In the last class, we have discussed about what is gravimetric analysis, that is principles, and what is gravimetric factor, and how we are going to estimate the gravimetric factor, and how to calculate the weight of the particular substance to be estimated. Everything we have discussed in the last class. Now we know what is gravimetric analysis and what are all the things we are doing in the gravimetric analysis. What is the main focus of gravimetric analysis we have discussed. Now we are going to discuss about, in this class, precipitating agent. What is precipitating agent? A reagent added to the solution of a substance to be estimated. If you are going to estimate or if you want to estimate a particular ion or a substance present in the solution, that ion or the substance to be precipitated first and then filtered, dried and everything we saw. To precipitate the particular ion to be estimated should be precipitated by using a reagent is called precipitating agent. This precipitating agent is also called as precipitant. Precipitant. For example, estimation of barium in a solution of chloride using barium chromate. When we are estimating the barium, in the barium we have the form of barium 2 plus ion. If we are going to estimate barium 2 plus ion, we are using here potassium chromate to precipitate and this barium 2 plus is precipitated as barium chromate. Here this is the precipitate has formed barium chromate. This formed precipitate, this precipitate is formed due to the reagent, by using of the reagent potassium dichromate. This potassium dichromate is called precipitating agent or precipitating reagent, or we can say that precipitant. So the precipitating agent is a reagent added to a solution of a substance to be estimated so as to the precipitate the substance is called a precipitating agent. For example, also we have discussed an ideal precipitating agent should react specially with ion or a substance to be estimated gravimetrically and give a precipitate. For example, which means an ideal precipitating agent. What is this ideal precipitating agent? Is react specifically with the ion or the substance to be estimated gravimetrically and give a precipitate. So this ideal precipitate should has some of the characteristics. So what are those characteristics of the precipitant? When the precipitate has sufficiently low soluble, so the precipitate formed in the gravimetric analysis should not dissolve at any cost. So the precipitate has sufficiently low solubility. So then therefore there will not be the loss of or losses of precipitate due to solubility of the precipitate. And the precipitant should be readily filtered. That is, not precipitant. The formed precipitate should be readily filtered and washed free of contamination. So, readily filtered and washed free of contamination. And so during when you are filtering the precipitate should be readily filtered, and during washing there should not arises any contaminations. The another one, the important characteristics of the precipitant should fulfill is that the precipitate formed which should not be unreactive. The formed precipitate should be not it is not reactive, it should be unreactive, and if it is and of a known composition of drying or if necessary ignition. So during heating or when you are doing other or in the room temperature and so at that time the formed precipitate should not be, which will not go out, which will not be volatile. So the formed precipitate must be unreactive. So if the formed precipitate should be unreactive means the precipitant should fulfill this characteristics. Then only the formed precipitate will be unreactive. Here we saw that the characteristic of precipitant, which means it says that the formed precipitate should not be soluble, and the formed precipitate should readily filtered and washed free of contaminations, and the formed precipitate will be and should be unreactive. Next, choice of precipitant. Precipitating agents may be inorganic or organic. So it is maybe inorganic or organic. But for example, for inorganic precipitant, some of the examples we shall see. When during the estimation of sulfate we are using barium sulfate. So not barium sulfate, barium chloride. Barium chloride to estimate the sulfate ion. Here the barium to estimate the sulfate we are using the barium chloride as a precipitating agent. And further, you have another examples when you are estimating the estimation of barium as well as and estimation of barium is estimated using the precipitant like sulfuric acid or potassium chromate. So this is also a precipitating agent. It is all the inorganic substance. So inorganic substance. So this all comes under inorganic precipitating agents. And another one example that already we know, when we to estimate silver ion, we use HCl as, that is hydrochloric acid, as precipitating agent to estimate silver ion. And further example, to estimate chloride ion. Already in the last class we have discussed it. We have used the precipitating agent is AgNO3, that is silver nitrate, and etc. So we have so much of many examples like this. If it is organic precipitating agent, some of the examples I give here: DMG, that is dimethyl glyoxime. It is used to estimate the nickel ion. And another example, I give some of the examples only here. Oxine. This oxine is also called as 8-hydroxyquinoline. 8-hydroxyquinoline. This is used to estimate aluminium. We saw some of the examples for precipitating agent, both for inorganic as well as organic. But the choice of precipitants for estimating metal ions is limited, as only one or two precipitants are there which satisfy all the requirements, which means all the requirements of the good precipitants. For estimating barium, here already we know that for estimating barium, already we have discussed it here. We'll see now also. During the estimation of the barium, we are using sulfuric acid. This is sulfuric acid and potassium chromate. To estimate the barium, we have used sulfuric acid and potassium chromate only. However, we can choose between an organic precipitant and also in the inorganic precipitant. For example, to estimate aluminium, we can use ammonium hydroxide. So ammonium hydroxide or oxine. So we can use both, whether the ammonium hydroxide or oxine as a precipitant to estimate the aluminium. But while using inorganic precipitant, we may come across co-precipitation or post-precipitation, and also we have some other causes. What is co-precipitation and what is post-precipitation? This co-precipitation means it is a phenomenon in which soluble compounds are removed from the solution during precipitate formation. So if it is a soluble compound is removed from, the soluble compounds are removed, then that is called co-precipitation. What is post-precipitation? This is the precipitation that occurs as a large layer upon already formed precipitate. It is surface-based contamination or impurity that occurs during or due to high primary absorption or supersaturation of the solutions. So, while using inorganic precipitant, we come across these problems: co-precipitation and post-precipitation. We will discuss co-precipitation, post-precipitation later in detail, because Now we shall see advantages of organic precipitant. Advantages of organic precipitant. Here I have given the advantages of organic precipitant. 1. The precipitate must be insoluble. The formed precipitate should be insoluble. If it is soluble, we could not estimate the exact amount of the substance or the ion to be estimated. So the formed precipitate should be insoluble, which means the given precipitate which are insoluble in water. So the quantitative precipitation is possible. Then the second one, the formula weight of the precipitate is larger with respect to the formula weight of the metal ion to be estimated. So that there is decreasing of the error. If the forming precipitate is the higher weight, if it is the heavier in weight, then the error is decreasing. Another one is during the filtration, the formed precipitate is higher and the particle size is higher. That is, the precipitant should give the large particle size. If it gives the large particle size, this makes the filtration and washing efficient. Okay, we can easily filter it and also wash the precipitate easily. And also, if the precipitate is the larger particles during the precipitation, it is easy. That is, drying of precipitant is easy, as organic compound have least tendency to retain water in them. We know organic compound is non-polar, so it won't attach with, or it won't join or combine with water molecule easily, because water is polar one. Water is polar. So when we use the non-polar compounds, that is organic compounds, the organic compounds will not easily stick with the water, and hence the drying of the precipitant is easy when we use organic compounds. Even though the organic precipitant has the advantages as using the precipitant, it has some disadvantages too. They are here I have given. During drying makes the composition of the precipitate uncertain. What happens here? Drying makes the composition of the precipitate uncertain. It happens. How it happens? When the organic substance are decomposed or volatile on heating. We know the melting and boiling point of organic compounds are less when we compare to the inorganic metal ions. So drying makes the composition of the precipitate uncertain, because it may get volatile, because we are using organic reagent as a precipitant or organic compound as a precipitant, so that it may get volatile. The found precipitate may get volatile on heating or get decomposed. So this is one of the disadvantages of using organic precipitant. The another one is the preparation of the solution of the precipitating agent is difficult. Here, how it is difficult? Preparation of the solution of the precipitating agent is difficult. Already I told that here the non-polar compounds does not readily stick with the water. We know that the polar and non-polar compounds are not combined as much easily. So as the solubility of these reagents in water is less, the preparation of the solution of the precipitating agent is difficult. So we need to prepare precipitating agent using organic compound. So for that, to preparation of the solution, we have to dissolve the precipitating agent in water. To dissolve this precipitating agent in water or the organic compound in water, it is difficult. For example, if we use DMG, already we saw that dimethyl glyoxine has to be, it is, if you take the DMG, if it is DMG is to be prepared, this DMG solution has to be prepared in cool as it is insoluble in water. We have to cool when you are preparing insoluble in, DMG solution in water. Therefore, there are two disadvantages when we are using organic compound as a precipitating agent. They are, we saw that precipitant may get uncertain, that is due to the volatile on heating, and the dissolving of the precipitate for the preparation of the solution is very difficult because it is insoluble in water. What is specific precipitants? The specific precipitants precipitates quantitatively a particular ion or substance from a solution. If the precipitants or the reagent, organic compound or the inorganic compound, which precipitates quantitatively a particular ion or a substance. If you want to estimate aluminum, means if the particular ion is used to precipitate the particularly aluminum, then that precipitant is called as specific precipitants. But usually there are no specific precipitants in reality. However, so in reality there is no specific precipitant. However, some of the precipitants may be mentioned or maybe act as which are nearly specific precipitants. We shall discuss about those specific precipitants. For example, dimethyl glyoxine. Dimethyl glyoxine is act as specific precipitant, and also oxine. Already we saw oxine. Oxine is also act as specific precipitant. So dimethyl glyoxine is act as a specific precipitant. It is the dimethyl glyoxine is a specific precipitant for estimating nickel in alkaline medium, the alkaline solution, and also this dimethyl glyoxine is used to estimate the palladium in acidic solution. It estimates the nickel in acidic medium, nickel in alkaline medium, palladium in acidic medium. So that it is nearly, it acts as somewhat nearly specific. So that I given the example dimethyl glyoxine. Like that, oxine, before the oxine. So this is the structure of which one? Nickel DMG, which is the precipitate formed. This is nickel DMG formed precipitate, forming precipitate. And then the structure of DMG is, which will be dimethyl glyoxine. It has 2 CH3 group, so that dimethyl double bond NOH. This is the structure of DMG. So this is formed from DMG. That is, if you are going to estimate the nickel, when you treat the nickel with this in the alkaline medium, for example, we take ammonium hydroxide, it forms this nickel DMG. Another one is oxine. It is also called as 8-hydroxyquinoline. We know quinoline, the structure of quinoline. The structure of quinoline is like this. In the naphthalene, instead of one carbon, we have nitrogen. So this is quinoline. In the 8th position, it has hydroxide, 8-hydroxyquinoline. This is also used as nearly specific precipitant. That is, this oxide is used to estimate aluminium from a that is solution around the pH 3. It is used to estimate the aluminium. Okay, by using this we can estimate this aluminium around the pH 3. When we treat this with the aluminium, it forms the compound will be like this. It is like 3 molecules of 8-hydroxyquinoline, which is combined with aluminium and gives this nitrogen here 3 times, and it eliminates hydrogen. H plus comes out. So aluminium is precipitated using 8-hydroxyquinoline or oxime. In addition to this, some other metals also be precipitated by using oxime. They are magnesium, copper, zinc, and all. So these are the ions also be estimated using oxime, because the solubilities of the oxygenates here forming the aluminum oxygenate, the formed precipitant is called oxygenate. Aluminum, if it is forming aluminum oxygenate or magnesium oxygenate, copper oxygenate, like that, zinc oxygenate is forming. These solubilities of these oxygenates vary from cation to cation. Thus, if it is magnesium, means the solubility is different from the copper compound, it is different from the zinc compound. So that, and these are all dependent on pH. So through the pH control, a considerable degree of selectivity can be achieved. So that by using this oxime, we can estimate these are the metal ions: aluminium, magnesium, copper, zinc, and so. So we know what is specific precipitants, and also we have a selective precipitant. We shall discuss about the selective precipitant in the next class. So far in this class we have discussed about precipitants, what is precipitant, and what are all the choices of precipitant, and we have discussed about inorganic precipitant, organic precipitant, and what are all the advantages of organic precipitant, disadvantages. We shall discuss in next class. Thank you.